Right, we are having our question on labor. Calculate earnings of workers A, B, and C under straight piece rate system. That is using straight piece rate system, Taylor's piece rate system, and Merrick's piece rate system from the following information. Right, as we had discussed earlier on, when we are doing our piece rate systems, the payment is on dollar per unit, right? And here we are told, let's take note of our rate. It's supposed to be dollar per unit. Let me put it there so that we remember that our rate is supposed to be dollar per unit, right? Normal rate per hour we are given as $80. Standard time per unit, it's 1 minute. Output per day for worker A, it's 380 units, worker B 460 units, and worker C 560 units. Working hours per day, it's 8 hours. So we are told that these workers A, B, and C, they produced 380 units, 460 units, 560 units. So we have to know what is the standard production, the normal production for the day, because the working hours per day it's 8 hours. So we are given that, let's put our formula. We have units, and then time, right? We are given that 1 minute is equal to 1 unit. Then 60 minutes, which is 1 hour, is equal to plus 60 minutes times 1 unit per minute. So meaning to say 60 minutes we produce 60 units. Then 8 hours, which is per day. How many units do they produce? So 8 hours, it's 8. Sorry, it's plus 8 hours a day times 60 units per hour. So the normal production in a day is going to be 480 units. So that is going to be our what? Our normal production, right? So when we now want to calculate using straight piece rate, it's going to be our 380 units times the rate, which is dollar per unit. Now we are given the rate, it's $8 per hour, which is 1.8 per hour. 1.8 dollars per what? Per 60 minutes, which is more or less the same. In 60 minutes we are producing how many units? We are producing 60 units. So our rate is good as saying plus $8 divided by 60 units, which is our rate is going to be 3 cents. Therefore our rate is going to be 3 cents in all aspects, because we cannot say $8 per hour, because our rate is supposed to be dollar per unit. Dollar amount per what? Per unit, which is $8 in 1 hour. How many units would have been produced? It's 60 units. So using straight piece rate system, A is going to get 380 times 3 cents, B 460 times 3 cents, C is equal to 560 times what? 3 cents. So A is going to get $11, B $14, C 17. Let me put dollar amounts there, and C $16.08. So that's that. Then we have got Taylor's differential piece rate system. On Taylor's differential, we have got these assumptions: any production less than 100%, we pay at what? at 80%. We pay at 80%. Production less than 100%, which is production less than the normal. Our normal production is 480 units. So any production that is less than our normal production, we are going to pay it 80%. Then production greater than production greater than the normal, we pay at what? At 120%. That is according to straight piece rate, to Taylor's differential piece rate system. Here we are told A produced 380 units, which is less than what? 480 units. So we are going to pay it at what? 80%. So how do we calculate that? So we are going to say it's equal to number of units produced times the rate times 80%, which is our rate there, our percentage rate for someone who would have produced less than the what, the normal, which is 480. Same applies to 460. The worker B who produced 460 units, it's less than what? 480 units. So we still apply the same what principle. It's going to be equal to 460 units times the rate 3 cents times 80%. This one, because the production is less than the normal, that's $11.04. Then C produced 560, which is far much than what the normal, which is 480. Therefore is going to be paid, or she's going to be paid at what? 120%. So our formula will be equal to 560 times the rate 3 cents times 120% times 1.2, which is 120. So C will get $20.16. So if you can see the difference on straight piece rate, A is getting $11.40. On Taylor's, using Taylor's differential, is getting $9.12. Worker B is getting $13.80 on straight piece rate. On Taylor's, $11.04. Worker C, $16.80 straight. Taylor's differential, $20.16. Then Merrick's multiple piece rate system, it asserts that production less than 83%, we pay at 100%. That is at normal rate. That is normal rate. Use the normal rate. Then production greater than 83%, but smaller than 100%, we pay at 110%. Then any production greater than 100%, we pay at 120%. So these are multiple rates that we are given under Merrick's multiple piece rate system. So we are now checking 380 units that were produced vis-a-vis 480. What will be our percentage? So when we are checking we want now to check for A, whether is it between less than 83 or between 83 and 100 or above 100. So we say plus 380 divided by what? 480, which is 79 what percent. Then B, 460 divided by 480. Sorry. Plus 460 divided by 480, which is going to be 96%. So which is between 83 and 100%. Then C plus 560 divided by 480, which is greater than what? 100%. 100%, which is 117%. Therefore, we now want to do the calculations. Worker A, he produced 380 units and the rate is 3 cents per unit. Then the rate we are using is normal because it produced less than what? 83%. So we are going to say plus 380 units times $3 per unit. So A is going to get $11.40. B produced 460 units. 460 units is 96% of the normal production, which is between 83% and 100%. So we're paying at what? 110%, so which is equal to 460 times the rate 3 cents times 110%, which is 1.1. So B is going to get $15.18. Then C is equal to 560 units that he produced, which are more than the normal for 80. So the rate is what? 120%, which is equal to 560 times the rate 3 cents times 1.2, which is 120%. So C is going to get $20.16, B $15.18, and A $11.40. So that's that for our question 1. So we now know under straight piece rate, A, you get that under Taylor's differential 9.12, Merrick's 11.4. That is for A. Then for B, we are having those amounts, and then for C, those amounts. That's that for that question. Thank you very much.